Hello and welcome everybody. So in this lecture we're going to take a look at the insertion sort algorithm. Now the idea of insertion sort is to have an array with a bunch of unsorted elements, and every time we take one element and put it in the correct position. For example, let's say here we have an array with a bunch of number elements, so -1, 3, -4, 6, 7, 2, 1, 1, 2, 1. So in order to start sorting, the idea basically is, well, the first one is sorted, the second one is sorted, so we have a counter here that starts from the very left to the very right, and every time we take an element and we basically insert it in the correct position. So this -4 should be shifted to the left. And then this 6 is sorted, this 7 is sorted, this 2 should be shifted before the 3, the 1 should be shifted before the 2, the other one should be shifted before the 2 should be shifted before the 3, and the 1 should be shifted before the 2. So that's basically the idea. Every time we take an element, starting from the very left to the very right, and that element we keep pushing it to the left until it reaches its correct position. Okay. So let's try to write an algorithm that will solve this problem. Alright, so the first thing in the algorithm should be a loop. So we have here a for loop. So for a variable index I starts at 0 up to n. Every time we're going to take the element number I, so that's, let's call this array t. So t of I, every time we're going to take that element and basically copy it into a temporary variable. Now that we have an element copied into a temporary variable, say for example this 4 here. So tmp has the number 4. Okay? So it has 4. -4, sorry. It has -4. Now that -4 there, we have to start pushing it to the left until we find its position. So let's do that. Basically, the first thing we have to do is so we have here, after copying this t of I inside temp, we have to create another counter. Let's call it j. J starts at I, okay? So if I here is 2, so that's 0, 1, 2, then J will start at 2, going backward until it reaches the correct position to put that -4, or it reaches the first, or it reaches the 0, okay? So either it's the smallest number, then it's going to be at the very, very left of the array, or it'll reach its correct position. So G takes I, and then basically let's create a while loop. So while J is bigger than 0, that means that we're still inside the array. Okay, so as I said now, either we reach the end of the array, the end of the left of the array, this end here, or we reach the correct position. Okay? So while J is bigger than 0 and T of J -1 is bigger than the temporary variable. Okay, so our number, the number we want to push, is stored inside the temporary variable. We always keep comparing that with the element at index T of J -1. If the TMP is bigger than, if the TMP is less than the T of J -1, it means that it has to be placed to its left. right? So we have to push the TMP to the left, and the T of j minus 1 should be pushed to the right, okay? So let's push it to the right. So T of j takes T of j minus 1. So basically that means that if we have an array here, this is j and this is j minus 1, so we take T of j, this one here, it takes T of j minus 1. And we keep pushing the T of j minus 2, we copy that into T of j minus 1, and so on. So that's the first thing. And the second thing, we have to decrement j, okay? And finally, when we found our correct position, the position where we're going to put our temporary variable, which is either we reached 0, the first element, or we reached the correct position. In either cases, we're going to copy the temporary element back to its place. So Tfj takes TMP. And 4. So basically this is the algorithm for insertion sort. Now let's try this in the C language and then get back here to deal with, speak a little bit about the complexity. All right, so here we have a project. I'm going to close this because it's with a different title. So new project. So I'm going to call this insertion sort. And basically I'm going to create a sample array. So let's say it has 5 elements, and let's generate 5 random elements. All right. So the function is called insertion sort. It takes an array, and it takes the size of the array, n. And as we mentioned before, the first thing we have to do, and basically the only thing in the outer loop, is a for loop. So we have here I and j, and then we have a for loop. So for I starts at 0 up to n, and every time we say that we're gonna create a temporary variable, so TMP takes array of I, and then g takes I, and then while g is bigger than 0, and the array of j minus 1 is bigger than TMP, we're gonna perform 2 instructions. So the first one, we say that we're gonna shift the element at array j minus 1 to the j position. So array of j takes array of j minus 1. And then we decrement j. And finally, inside the for loop, the fourth instruction would be to copy inside the array of j the temporary element. All right, now this is basically the implementation of the algorithm. Now let's write a function that will print the array so that we can see whether it got sorted correctly or not. So the function would, let's call this print array. It takes the array variable and the size of the array, and then we have a variable I that starts at 0 up to n, and then every time we're gonna print out to the screen a number, a decimal, and then a tabulation. It'll print the number array of I. Cool. Now inside the main function here we have a sample array, and we're going to print the array So that's print the array. And the size of the array is 5. Let's make it here print a new line after printing all the elements. All right, cool. Now we print the array, and then let's sort the array. So let's sort the array. So insertion sort. We give it the array and the size of the array, and then let's print the array again to see whether it got sorted or not. Cool. And as you can see, these are the this is the array before sorting it, and this is before and this is after sorting it. So minus 13, 23, 32, 54, and 5, 44. So the array got sorted correctly. Cool. Now if we get back here to the analysis, and basically the complexity of this algorithm is, well, here we have order 1 instructions, so these are constant. We have here a constant operation, and then we have a while loop. Now this while loop is order n. Why order n? Well, let's see. We have j always starts at I, okay? J always takes I. And at the worst case, I goes from 0 up to n, which means that the worst case, j would start at n, okay? And j starts decrementing until it reaches 0. That's the worst case. Either it finds its position or it reaches 0, okay? So if it reaches 0 and then it starts from n, then it's going, at worst case, perform an operation, okay? It's going to perform an iteration. Every iteration has a constant operation. So that's order n times order 1, so that's order n. Okay? But then we have this order 1 plus order n plus order 1. This is order 1. So order 1 plus order n plus order 1, so that's order n, okay? And since we have in the inner loop, so the inner loop, let's take away this. Cool. So we have here, so we have here this inner loop. This inner loop takes order n. But we have this inner loop being repeated n times because I starts from 0 up to n. So that's order n times n, so that's order n squared. But this algorithm is a quadratic algorithm. It's quadratic complexity algorithm. It takes order n squared. Okay? And that's it for this video. See you next time.